Hi all, Bones here from BSA Bantam, standing in the skylight, obviously in the shed, and my little helper Levi just here as well. So welcome back to the workshop and welcome back to the channel. In this episode what we're going to be doing is progressing on the race bike a bit more. Got a bit of help in hand and I'll show you a little bit of an issue that we might have to overcome. It's not a huge issue, but I'll show you. So I've just been sitting up on the bike and I'll draw your attention to the footrest rod bar there. So we come further around in the line of the bike, you can see how much of it isn't actually sticking out. Obviously because I've got all this distance now because of the tuned pipe. So what we're doing now is we're fitting up, or actually taking that footrest rod bar out, and we're going to make one that's extended by 1.5 inches. Levi's just had the ruler out. I've sat up on the bike and just worked out we need an extra 1.5 inches to make things a bit more comfortable. On the other side, it's spot on. So I don't want to like shimmy the whole footrest rod bar across because I'll reduce my contact area with my feet on the other side. The only drawback, and I don't think I can get away from it, is by extending it, it reduces my ground clearance when I corner. So not that I'm going to be cornering that hard anyway, and my leg actually does sit pretty close to the pipe here in the configuration that it currently is. So by having another, it's 1.5 inches to come out here, and I'll make an alloy heat shield to just go over that portion just there, and I think it'll be fine. I actually got some heat shield matting, like adhesive stuff, which I'll put on the inside of that, and I think just an alloy heat shield there will work fine. I'll just weld some like threaded bosses on there so I can screw straight onto the pipe. But we'll get some bar stock cut off and get some threads on it, and then make some more modified spacers. Like these ones obviously aren't steel like the originals. I've made them out of aluminium. Well, I didn't make them, I actually had them when I bought a job lot of stuff. Someone had started making some of them up out of alloy. Anyway, so I've got some alloy ones there. We'll make them, get another one out and we'll modify that. So I've got Levi just cutting off a bit of 1/2 inch bar stock as we speak, and we'll face that off, put a chamfer on it, and we'll cut 2 threads on the end of it. Good work, matey. So we have little man on the lathe who's just going to face this bar stock off for me. Go for it, matey. That's it, good boy. Now wind out, that's it. In a little bit. And that's it. That's exactly right. Well done. Yeah, good work. So what we're doing now is cutting the thread on the end of this footrest rod bar. I'm just obviously standing at the tailstock, backing up the button die holder to keep it nice and square as Levi's cutting the thread. So what I've done here is I've actually made up a whole new intermediate lever, and I've made it slightly longer to get us a bit more mechanical advantage. So it'll have to go underneath like that. Levi's finished the footrest rod. On standard Bantam, these are all steel, but obviously we've changed them out to aluminium for weight saving. Because we don't have a centre stand, we've had to put make a bush up for the brake pedal to sit up against to position it in the correct position. We've had to use a centre stand stop plate because that positions your brake pedal when the spring tension's on it, and it also allows your brake pedal return spring to hook into something. So you've got to have that. So in order to save a bit of weight, we've cut the end off that and just rounded it off. You're right there, little man?
Yeah.
Very good. So we're very happy with that. It's turned out really well. So now what we're up to is up here and start trimming the steering stop back just to get it in the right position in relation to the body. I've got the body off, tuck in there with a grinder, an old pair of overalls down there to catch the grinding sparks. So we continue. Alright, so what I'm doing now is starting to work out position of, I'll need a heat shield here. I have extended this footrest rod bar out a little bit, but I'm just working out the position of the heat shield that I'll need, which is, it's neither here nor there. I've got the side covers back on because I'm also making brackets to stop them flapping around. So obviously the one on the near side can come straight off the frame. This one will have to come off the exhaust, of course, because the exhaust is hanging out. No big drama. I've cut them, getting them positioned, ready to go. So what I might go on to now is this heat shield. I think I'll do an aluminium one. And I'm just cogitating in my brain how I'm going to go about it. I think that'll work. Something about that big. I'll round off, put a radii here, cut it out and see how it looks. It's sort of the shape I've come up with. Yeah, that's going to give me enough. That's going to wrap around enough to stop any radiant heat coming off and up from the exhaust, because obviously your leg's sitting over this, so you're going to have a fair bit of heat here. Carbon fibre, this will be lined with heat shielding on the inside as well, so I'm not worried about that. It's just my leg here because it does sit pretty close. Yeah, I think I might do a polished stainless cover. I might put this template out onto material and cut it out and roll it and see how we look. Because the thing is, I've got to have some threaded bosses that I'll have to weld off here, and I've got to bring the TIG welder around to weld the brackets anyway, so I might as well get all this done while I've got the welder set up around this side. All right, there's my heat shield. I'm going to start rolling it up now. So I'll set the rollers and we will get stuck into it. Aha, bastard, slipped. Not what I wanted. That's better. No, it's set to go. Might have to take this off. So I've got my heat shield done. and I've got my little standoffs machined up and just marked out here, so it will sit there something along the lines like that. I have marked out around them, and I'm going to have a bit of a challenge. I'm just going to have to hold it there and strike an arc and see if I can get it to just join up, because I won't have a third hand for any filler rod, so we'll see how we go. Got a bracket to put in up here, straight onto the pipe, and a bracket around the other side as well. So it's progressing pretty well. The bugger of the thing is that they're about 16mm diameter. It's a public holiday, nothing's open, and the only lump of stainless I had is 60mm in diameter. So it took a bit of whittling away to get it down to that size. But anyway, the joys of it all, eh? So there's the stubs welded on for our heat shield, which is down there. You can see that bracket coming out there. That's for the side cover. And around here, we've just welded this bracket on here, and that's for the other side cover. That'll retain the bottom of the other side cover. So I think that'll do me for today. It's time to do a bit of pack up. Workshop's looking a bit grubby, but yeah, progressing really well. There's a lot of stuff coming off the list. A few things going back on, I might add, but anyway, it's going good. Actually, I've got to strike a few more off that right there now. So I've got our body back on, and looking at my heat shield, I'm actually really happy with it. I wasn't, there was something about it before. I didn't think I had it rotated around enough, but most of the heat's going to be generated up, and my leg's coming across through here. So it does come round down the side here, but it's going to protect around. I've got a good standoff distance, that's 12mm I made it, to give myself plenty of room. The other brackets I've just worked with an absolute treat. So like I'll put a, sorry about that guys, I'll put a screw through there, and that's, and then around here it's right in about the center where I want it, because the other reason I'm trying to keep things still looking all right. I mean, I don't want to screw just over here. I'm going to try and like to get it central if I can. And it's the same deal with this one. Just let me feel around, so it's right there. So yeah, pretty good day's effort today, and we'll continue tomorrow. Keep going, get all these little jobbies out of the way. So a bit of a short interlude from working on the race bike. I have to do some BSA Bantam stuff. So trying to make a press die, because I've run out of steering stem caps. If you're not sure what a steering stem cap is, we'll go and have a look on the bike. So that's the steering stem cap up in here that sits on top of your bearings and is sandwiched by your top yoke on all the bikes. I've run out of these. No one makes them. We need them. So time to make a die. So I've done my calculations out there, just a bit of a rough drawing and how I'm going to go about it. This is the laser cut coupon that I'll be pressing it out. And over here in the lathe at the moment, I'm just making the male portion of the press die. So that's the bit that'll go on top and press it down through into the female portion of the die. So I've got that bit done. I'm going to set up another bit of metal and I'll machine up the female die. So this is the start of the female die. You can see I bought a half-inch hole at the middle. And now I'm going to start counter boring the actual female part of the die where the coupon will be pressed into. So over here to our drawing. So we want a bore size of 57.25. So 55.35, 57.25, and effectively what we've got is this is bigger than that to allow for the thickness of the material that has to be pressed down in here. What I don't want is once the coupon goes in and starts being pressed is an interference fit. That'll tear the material. So this has got 0.05 of a millimetre clearance. So we'll get to and we'll bore this out. So we're getting down close-ish to the bore size that we need. Whilst that looks pretty deep, I mean the thickness of the job's only 1/4 inch once it's been pressed. I'll need a radius in here so as it's being pressed in, it actually forms the metal. But we'll show you that once I get a bit more out of this and get this to size. Hole up the middle. That's for a guide pin to keep everything centralised when we're pressing. So I've got this roughed out. We are only about 1 millimetre off size, so I'm trying to drag the telescopic gauges and micrometer out. So now I've bored out down to depth, and I've also put a rotating shoulder in here for the coupon to sit in. So that's central, absolutely centralised. So then our other piece will come through and push on this. What I have to do now is see this really sharp edge here. I have to start blending that off on an angle, sort of on about that angle heading that way, to allow the male part of the die to push it down into the female part. So only about, I'll try and poke, only about that portion down there will be parallel. The rest will be tapered to allow this coupon to form. Just something I'll quickly explain as well. This male portion of the press die will actually shoulder out up here on this bit here to ensure that you've got clearance down at the bottom here of 0.93. The thickness of the material is 0.90. That way, when you're pressing down, it doesn't actually crush this bottom portion of your coupon. So you only want it to press it the actual thickness. So we've made allowance for that as well. So there are our components. So we drop our coupon into there. That's the guide, and then we press it down. So there's only one thing left to do, and that's press it and see if it works. Right, set up on the corner of the bench. Not ideal. I don't have a cameraman. I'm not that big a YouTube person, but anyway. I'm just pumping this down. Now this press is a 20-ton press. Right, and here we go. Right, I'm going to try and bring it in a bit closer, as you can see it. I don't know, you can see the edge of it there as it's being pulled down into the die. It's just rolling up that edge. Pretty soon the whole lot should start disappearing down. That's great. and we'll finish it off, and we'll go all the way, pump it all the way down to the bottom. That's it. Now let's see how we go. Put you back up there. I do think this might be a potential issue. Get them separated. Maybe I should have put another lip in there. Anyway, got a little bit of a job on my hands with the centre punch, just knocking the centre back out. So I'll get that done and we'll see what we ended up with. Well, the joys of making dies. So, as you can see, it's still together because it is stuck well and truly. So what I'm going to have to do, I'm going to weld these tabs on, and in there you can just see, make out, I've actually counterbored this out so I can get a bigger piece of bar stock to be able to press them apart. My sneaking suspicions, and I won't know until we get it apart and I have a look at the pressed up component, is I'm a fraction tight on my tolerances, but I've worked it all out and I know I've got clearance. So and if people say, oh well, you should have preempted this, well, yes and no. This is the first one I've ever had that's stuck together, and I do a few like things like your clutch, little clutch cover on the side of the engine. That's one of the pressed ones we make. There's a couple of others anyway. So yeah, this is the first one I've got stuck, but anyway, and it may be that other things that can happen too is that once it's pushing down in there and it starts shearing metal off, well, that's extra bits of metal that take up the tolerance and could fall in there and get like clag it up as well. So if that's the case, we'll just have to open up, polish out our tolerances a little bit. But anyway, first of all, I've got to get it apart. All right, so we've got it out, and I'm looking at this surface finish on the edge and I'm seeing horizontal lines going that way, which means that they're drag marks. They're not big gouges, but the thing that's a bit of a telltale to me is that it's shiny. So that means it is probably too, well, it's not probably, it is too tight in the die. So I am going to put this back in and give it a shave in this diameter in here. That's why I didn't weld these tabs on all the way back here, so I can grab hold of it again. So like compression wise, there's no marks on it internally. It actually looks pretty good, but it's a little bit, that's under a better compression there. I've obviously, well, that's another good point. It hasn't drawn down quite square into the die, or was that getting it out? I'm not sure. I might have been hydraulicking it. When it was being hydraulicked out, it actually pulled it back out, I think. So, because it all came down nice and square when we'll put the first one in. But anyway, we need a little bit out of here, so we'll get that done and we'll give it another go. Oh, I'll tell you the other thing I have to do is I've got to make another guide pin because I've bored this out to give myself a shoulder to press against that. So, but it'll be all right. Rightio, take two. What have I done? I've increased the diameter in there, decreased the diameter on that, made a stepped guide pin. It's still sitting there nicely. I must admit, I was concerned about getting distortion from the welding, but it doesn't seem to be the case. I'll pull those together. And we need that. Right, let's go. Let's give it a go. See if we can get it stuck again. all down. All right, the guide pin comes out. They're still tight in there, but we have a ways and means to separate now. Get that out of the way. Alright, so it's still reasonably tight, but if it produces a good product that I can get out easily, I'll use it. Oh, rightio. It's really interesting. It's actually wanting to come out. I don't know whether you can see that, but you can just see it lifting there as it's coming back out of the die. I am looking circumferentially around here to make sure we've got no real reduction in thickness, and we haven't, so that's telling me my clearances and everything is still right. Right, I'm going to try something here. It's going to get noisy, sorry. So we punching another one out after a few mods, which is going very well. So that comes straight out now, and we still have our coupon in here, but what I've ended up doing is drilling 4 little holes there, and I use a pin punch just to knock it out. And that's what we're ended up with, exactly what we're after. Steering stem dust cover. So very happy. It's come out good. I knew I'd get there in the end. I destroyed about, I'll just turn it around. I destroyed about, where are they? 1, 2, 3, 5. I destroyed 5 getting it right. When I'm changing the tolerance, I'm not changing it, you know, taking 0.2 or whatever, I'm taking 0.02 or polish or 0.05 of a mil, because I mean, I don't know whether you'll be able to pick that up. These got to be nice and square, so if you increase your clearances between your male and your female too much, well, they end up like flared and it looks shit house in a nutshell. So, that's the way it turned out. And here's the other ones were all pressed up all right, it was getting them out. So I genuinely haven't had this much trouble before on a die like this, but it's no big deal. So, you know, I've got to do a production run. I think I was going to do, interestingly enough, I wanted 50 and I've ordered 55. And there's a very good reason for that, because I knew I'm going to have some stuff ups along the way. So yeah, that actually worked out really well, didn't it? And I do that, order extra stuff when I am developing a die. But anyway, it works. I'll get back on to pressing them all out. So I think that might do it for this video. So I really hope you've enjoyed the upgrade work on the race bike, which is really starting to progress, and I'm starting to feel like pretty good about, you know, we're in the home straight, literally, for the actual bike itself. So that's progressing really well. If you've enjoyed this video, please hit like or subscribe. I hope you've enjoyed the little bit of an insight about how challenging it can actually be making some dies, unlike the last one, which was, you know, worked like a treat straight off the bat. I can tell you they don't usually do that. It's more like this. You just have to fettle it a bit and just get it to work right. There's no point if it doesn't work right, because you've got to produce a product at the end that's right. So we've done that, we've achieved that. So if you want to know how long it sort of took me, what's the time is about, I'm going to say 5 to 6 hours. to actual build the dye would have taken me 3, and I reckon it's taken me 2 hours just fettling and putting the dye back in to get it running absolutely spot on with the dial indicator. Take a skim, polish, bring it out, press. Nah, doesn't work. So yeah, I'd say 5 to 6 hours all up. But anyway, that's the way it goes. Anyway, thanks very much for watching. Stay tuned, and next run will probably be, I have absolutely no idea because I'm getting ready to go on holiday soon. Actually, we've got to go to Bendigo Swap Meet. So, but anyway, there's always plenty going on, and we'll keep posting stuff if you keep watching. Rightio. So from Bones and Oz BSA Bantams, I'll see you later.